Welcome, and thank you for joining me today. We are living in a moment where the boundary between human capability and machine intelligence is quietly but steadily shifting. Tasks that once required human balance, judgment, and coordination are now being explored by machines designed in our own image. Among these, one humanoid robot has captured the attention of engineers, researchers, and industry leaders alike: Atlas. Atlas is not built to impress with spectacle alone. It exists as a serious attempt to answer an important question: can a machine safely and effectively operate in environments created for humans? From homes filled with everyday objects to factories assembling complex machines like cars, Atlas represents a thoughtful step toward that future. In this video, I will respectfully guide you through what Atlas truly is, beyond viral clips and dramatic headlines. We will look at how this humanoid robot is trained to move with balance and precision, how it interprets the physical world around it, and why its design makes it suitable for tasks ranging from basic object handling to demanding industrial labor. It is equally important to approach this topic with realism. Atlas is powerful, but it is not perfect. It does not replace human creativity, empathy, or judgment. Instead, it reflects decades of careful research in robotics, control systems, and artificial intelligence, progress built slowly, one challenge at a time. I will help you understand not only what Atlas can do today, but also what remains difficult and why responsible development matters. If you are watching as a learner, a technology enthusiast, or a thoughtful observer of the future, I invite you to see this as a journey of understanding rather than prediction. This is not about fear or fantasy, but about knowledge. With patience and curiosity, let us now explore how Atlas moves from simple human-like tasks to complex work such as car repair, and what that means for the world ahead. What is Atlas? Before we discuss what Atlas can do, it is important to understand what Atlas truly is. Atlas is a humanoid robot developed by Boston Dynamics, a company known worldwide for pushing the boundaries of robotic mobility and control. Unlike traditional industrial robots that are fixed in place or move along predefined tracks, Atlas is designed to move through the world on two legs, much like a human being. This design choice is intentional. Our homes, factories, and cities are built for human bodies, not machines. At its core, Atlas is an advanced electromechanical system that combines precision engineering with artificial intelligence. It stands roughly human-sized, with articulated arms, legs, and a torso capable of complex motion. Every joint is powered by electric actuators, allowing for smoother, quieter, and more efficient movement compared to earlier hydraulic systems. This shift reflects a broader trend in robotics toward energy efficiency and real-world practicality. What makes Atlas particularly remarkable is not just its physical form, but its purpose. Atlas is not designed as a toy, nor as a distant futuristic concept. Instead, it serves as a platform for exploring how humanoid robots can assist with real, meaningful work, especially in environments where wheeled robots struggle. Tasks such as climbing stairs, navigating uneven ground, lifting objects, or repositioning materials are all part of its intended role. It is also important to approach Atlas with the right expectations. Atlas is not a fully autonomous, general-purpose human replacement. Rather, it is a carefully engineered system that demonstrates what is possible when perception, balance, control theory, and machine learning are combined thoughtfully. Each movement we see in demonstrations represents years of research, testing, and refinement. As we move forward, keep this in mind. Atlas is best understood not as a finished product, but as a milestone, a bridge between human capability and robotic assistance. With that foundation established, we can now explore how Atlas moves, senses, and responds to the world around it. How Atlas moves and thinks. Now that we understand what Atlas is, let us gently explore how it is able to move and make decisions in the physical world. At first glance, Atlas appears to move effortlessly, walking, lifting, turning, and balancing with a fluidity that resembles human motion. However, beneath this smooth exterior lies an intricate coordination of hardware and software working together in real time. Engineers at Boston Dynamics often describe Atlas as a system that is constantly sensing, predicting, and adjusting. Atlas relies on a network of sensors to perceive its surroundings. These include vision systems, depth sensors, and proprioceptive sensors embedded within its joint. Together, they allow the robot to understand where its limbs are positioned, what objects are nearby, and how its body is oriented in space. This continuous stream of information forms Atlas's awareness of the world. Once perception is established, the robot's control system takes over. Rather than following rigid, pre-scripted movements, Atlas uses advanced motion planning and optimization-based control. This means it calculates full body movements dynamically, adjusting its posture and balance every fraction of a second. If the ground shifts, if an object moves, or if a task changes slightly, Atlas can respond without falling or freezing. Equally important is the role of artificial intelligence and machine learning. Atlas is trained using a combination of simulation and real-world testing, allowing it to refine behaviors over time. Through this process, it learns efficient ways to grasp objects, distribute weight, and coordinate arms and legs as a single system rather than separate parts. It is important to note that Atlas does not think in a human sense. It does not possess intention or awareness. Instead, it executes highly optimized responses based on mathematics, physics, and learned models. What we observe as intelligence is the result of careful design and rigorous testing. Understanding this balance between sensing, control, and learning helps us appreciate why Atlas is such a significant achievement and why its movements feel so natural, even though they are entirely artificial. From housework to car repair, what Atlas can do. With an understanding of how Atlas moves and perceives the world, we can now explore what truly captures public attention: the tasks Atlas is capable of performing. At a smaller scale, often compared to household activities, Atlas demonstrates skills such as picking up objects, carrying loads, placing items with precision, and navigating spaces designed for humans. These actions may appear simple, but they require an extraordinary level of coordination. Grasping an object involves vision, balance, grip force control, and posture adjustment, all happening simultaneously. In controlled environments, Atlas performs these tasks with increasing reliability, offering a glimpse into how humanoid robots might one day assist with repetitive or physically demanding chores. However, it is important to be honest and careful here. A real home is unpredictable. Objects vary in texture, weight, and fragility, and humans move unpredictably. While Atlas can demonstrate household-like tasks, it is not yet designed for unsupervised domestic use. These demonstrations are best understood as stepping stones rather than finished solutions. Where Atlas truly begins to shine is in industrial settings. Developed by Boston Dynamics with a focus on real-world deployment, Atlas is being shaped for environments such as factories, warehouses, and automotive assembly lines. In these spaces, Atlas can move parts, lift heavy components, reposition tools, and assist with material handling tasks that are physically demanding or unsafe for humans. In the context of car manufacturing and repair-related workflows, Atlas's humanoid form becomes an advantage. It can reach shelves, walk between stations, climb steps, and operate in layouts originally built for human workers, without requiring extensive redesign of the workspace. Seen together, these capabilities reveal an important truth. Atlas is not about replacing humans in every task. Instead, it is about extending human capability, taking on repetitive, strenuous, or hazardous work while allowing people to focus on supervision, creativity, and decision-making. This balance is where Atlas finds its true purpose: limitations, safety, and ethical responsibility. As impressive as Atlas may appear, it is important to approach this technology with realism and responsibility. True understanding does not come from admiration alone, but from acknowledging limitations and addressing concerns with care. One of the most significant challenges Atlas faces is reliability in unstructured environment. While the robot performs well in controlled industrial settings, real-world spaces are unpredictable. Objects may shift unexpectedly, lighting conditions can change, and surfaces may be uneven or unstable. Handling soft, fragile, or irregular items, something humans do intuitively, remains a complex problem for robots, including Atlas. Another key limitation involves endurance and energy efficiency. Humanoid robots require significant power to maintain balance, perform dynamic movements, and carry load. Battery life, heat management, and long-duration operation are ongoing areas of research. These constraints currently limit how long Atlas can work continuously without recharging or supervision. Safety is an equally critical consideration. Atlas is strong and fast, which means it must operate with extreme caution around people. Developers at Boston Dynamics place a strong emphasis on human-aware motion planning, collision avoidance, and controlled force application. Extensive testing and safeguards are necessary before any humanoid robot can be trusted to share spaces with human workers. Beyond technical concerns, there are ethical questions that deserve thoughtful attention. The introduction of humanoid robots into workplaces raises issues related to job displacement, workforce transition, and societal impact. Responsible deployment means using robots to reduce injury, fatigue, and dangerous labor, not to disregard human dignity or economic stability. It is also important to resist exaggerated expectations. Atlas does not possess consciousness, emotions, or moral judgment. It follows mathematical models and learned behaviors, nothing more. Treating it as a tool rather than a replacement for human agency helps ensure ethical and productive use. By recognizing these limitations and responsibilities, we gain a clearer, more grounded view of Atlas, one that values safety, transparency, and thoughtful progress over spectacle. Real-world deployment and industry momentum. After understanding Atlas's capabilities and limitations, a natural question arises: where is this technology actually being used today? To answer this, we must look beyond demonstrations and toward real-world planning and deployment. In recent years, Atlas has moved steadily from a research-focused platform toward practical industrial application. The team at Boston Dynamics has clearly stated that the future of Atlas lies in enterprise environments, places where repetitive, physically demanding, or hazardous tasks are common. Factories, warehouses, and logistics centers are among the most promising settings. A significant driver of this momentum is the interest from major manufacturers, particularly in the automotive sector. Industrial facilities are often structured, predictable, and standardized, conditions that allow humanoid robots like Atlas to perform reliably. Tasks such as transporting heavy components, repositioning parts between stations, or working in tight spaces are areas where Atlas's mobility offers clear advantages over fixed or wheeled robots. Public showcases and industry events have reinforced this direction. Demonstrations presented at major technology exhibitions and engineering conferences show Atlas performing increasingly practical workflows rather than acrobatic stunts. This shift is intentional. It reflects a broader understanding that long-term success in robotics depends on usefulness, safety, and integration, not spectacle. However, it is important to note that deployment is cautious and gradual. Early implementations are expected to be supervised, task-specific, and limited in scope. Engineers gather data, refine behaviors, and improve reliability before expanding usage. This slow, methodical approach helps ensure trust and safety while allowing the technology to mature. Taken together, these developments suggest that Atlas is entering a transitional phase, moving from experimental research into applied industrial support. While widespread adoption will take time, the progress made so far indicates a serious commitment to making humanoid robots a functional part of modern industry. As we come to the end of this exploration, I invite you to pause for a moment and reflect on what Atlas truly represents. Atlas is not simply a machine that walks, lifts, or carries objects. It is the result of decades of human curiosity, discipline, and persistence, a reminder that meaningful technological progress is rarely sudden or effortless. Every step Atlas takes, every object it lifts, and every task it completes is built upon layers of mathematics, physics, engineering, and careful ethical consideration. Throughout this journey, we have seen that Atlas is neither a miracle solution nor a distant fantasy. Developed by Boston Dynamics, it stands as a practical experiment in how humanoid robots might assist humans in environments designed for human bodies. From controlled demonstrations of household-like tasks to serious industrial applications such as automotive assembly, Atlas shows us both what is possible today and what still requires patience and responsibility. It is important to remember that the future of robotics is not about replacing people, but about supporting them. Machines like Atlas are best understood as tools, capable of reducing physical strain, improving safety, and handling tasks that are repetitive or dangerous. It is important to remember that the future of robotics is not about replacing people, but about supporting them. Machines like Atlas are best understood as tools, capable of reducing physical strain, improving safety, and handling tasks that are repetitive or dangerous. Human judgment, creativity, and compassion remain irreplaceable. If you are a learner, a student, or simply a curious observer, I encourage you to continue asking thoughtful questions. Read deeply, examine claims carefully, and approach new technology with both optimism and humility. Progress guided by wisdom is far more powerful than progress driven by excitement alone. Thank you sincerely for spending your time here. If this exploration helped clarify your understanding, consider sharing your thoughts or questions. Meaningful dialogue is how knowledge grows. Until we meet again, may your curiosity remain steady, your questions sincere, and your learning continuous.